Hello, this is Mr. Stein, and in this video we're going to go and look at example number 2 from section 7.4, using a substitution strategy to solve a system of linear equations. Let's head on over to example 2. Example 2. Create a linear system to model this situation. Alexa invested $1,800, part at an annual interest rate of 3.5% and the rest at an annual interest rate of 4.5%. After 1 year, the total interest was $73. So the first thing we're going to do is we're going to create a system of linear equations. Number 1, define our variables. We are going to use L to be the amount invested at, so the amount of money invested at 3.5%. I used L to indicate low percent. H to be the amount in dollars invested at 4.5%. Why didn't you just invest it all at 4.5%? That would make more sense, wouldn't it? Higher interest rate, more money back. Maybe there's some other issues involved. Number 2, define our variables. We've just defined our variables. Number 2, restrict our variables. So L, such that L has to be bigger than or equal to 0. We can't have negative amounts, but we can have decimals. And L could be an element of the reals. Well, not really a full element of the reals, but pretty darn close. We'll say it's going to be close enough for that because we can have decimal numbers in here. All right, so we have defined our variables L and H. We have restricted our variables. Now we need to identify where the equations are. First off, she invested a total of $1,800, right? Total. So the amount that she invested at 3.5% plus the amount that she invested at 4.5% will be $1,800. So for number 3 are two equations. Our first equation is L plus H is equal to $1,800. Now, second one, the total interest was $73. So the interest she made at the low amount plus the interest she made at the high amount will give us $73. So the interest she made at the low amount, you take her interest rate, 0.035, times it by the amount of money she invested at that interest rate, plus take her 0.045, times it by the amount that she invested at the higher rate, and the total of these two interest amounts is $73. Okay, so again, I'll just highlight this. This is the amount of interest she earned on the low interest rate account. This is the amount of interest she would earn on the high interest rate account. The total of that interest is $73. Good. Letter A is done. We've created a linear system. Now let's move on to letter B. Letter B is solve this problem. How much did Alexa invest at each rate? So the first thing we need to do is we need to identify a variable that we can isolate. Now, either of these two variables are really easy to isolate. So let's isolate, let's say, L. So we're going to isolate L. L is equal to 1,800 minus H. Right, we took this H and we moved it over. Good. So step 1. Identify a variable you can isolate and isolate it. Step number 2. We take this thing here that equals to L and we put it into our other equation where L is. So this is step number 2 that we're on. We substitute it into the other equation. So again, I'm going to try to color code this. We have 0.035 times plus 0.045 equal, I need my variable here, h equals 73. So now I take this, which is equal to L, and I put it where L was, 1800 minus h. There we go. Now I solve for my variables. So we're on step 3. We're going to solve for my variable h. So to do that, I take my 0.35 and I'd multiply it in. Now I need a calculator for this one. 0.035 times 1,800 is equal to 63. So you get 63 minus 0.035h plus 0.045h equals 73. Not bad. Let's keep solving it. I can combine these like terms here to get 63 plus 0.01h equals 73. Not bad. Subtract 63 from both sides to get 0.01h is equal to 10. Not too bad. Multiply each side by 100, or divide by 0.01. H is equal to 1,000. So we found out what h is equal to. H is equal to 1,000. Now if h is equal to 1,000, how much is L equal to? So we take our 1,000 in step 4. We take our 1,000 and we plug it into another equation to figure out what L is. So we get L plus 1,000 equals 1,800. And so L will equal 800. So for our answer, we get H, the amount that she invests into the high savings, the high interest account is 1,000, and L is equal to 800. That's the amount that she invests into the low account. Now, we can verify this. It's pretty easy to verify in our first equation here. L plus H equals 1,800. 800 plus 1,000 equals 1,800. So let's verify it in our second equation just to check it. So we're going to verify 0.035 times 800 plus 0.045 times 1,000. Does that equal $73? All right, so let's do this up. 0.035 times 800 equals $28 plus $45. Does that equal 73? Yes, it does. We just verified. This would be like step 5, verify. We verified it. It works. She invested $1,000 into the high interest account and $800 into the low interest account. Now, in practical terms, she might have invested some into the low interest account because there's more security or some other feature of that account that she needed. Like maybe it would allow her to access the money more easily than the high interest account. All right, so I hope you found this helpful. Remember to go through all these different steps when solving a full problem. If you have any questions, please contact me or put them right in the comments. And thank you for watching.